Welcome. This is a new thing I'm going to try. I'm on page 449 in the textbook now, and I'm going to look at questions 1, 2 and 3. And what we're trying to do here is we're trying to promote proper answering, not shortcutting. Really, it's exam technique is really what I want to look at and where the marks are. What am I going to ask you to do? I'm going to ask you to watch this video, and then I'm going to ask you to do the first questions 1, 2 and 3. And then I'm going to ask you to photograph it or upload it whatever way you can into Google Classroom, and then I'm going to mark it. So that's what this video is about. So it's about how to improve your answers and for you to submit work up to me via Google Classroom. Now, I was most disappointed when I looked back on the Google Classroom on Brian Cox planets. I got 8 out of 24, but those 8 people who did it all got full marks, and that's recorded as full marks. I need evidence to see that you're working. So this is the start of the evidence that I will be collating to show that you're working. If you don't hand it up, you get 0. I have no evidence. You take from that what you want. So I'm going to look at these 3 questions. I'm going to do them on the data pen here, and then we're going to see, can you upload this back to me? So let's do question 1, and we're in page 449. That's where we are, and we're looking at question 1. So I'll read out the question and then you do it, and then watch it being done, then you do it, you submit it, and I'll mark it. State 4 properties of the image in a plane mirror. Well, they are on page 438, so it's there to be learned, page 438, and we'll just write down what they are. Right, we'll just write down exactly what they are. Right, so the first thing is, the image in a plane mirror is virtual. A bit like Santa, doesn't really exist. I mean, that's a shock. So you cannot put your image on a mirror on a screen, so that's why it's virtual. It's laterally inverted. That means left becomes right and right becomes left. Right? It's the same size as the object. Now we're talking about a plane mirror here, we're not talking about a curved mirror. And finally, same object, same distance in front as images behind. Now you notice I'm using full sentences, well, apart from the first 3. Object, same distance in front of mirror as images behind. And that's it. Now there's 4 marks. So again, we're trying to get our, if you look at the mark scheme, it says 4 marks. There's 1, 2, 3, 4. We know what virtual means, we know what laterally inverted means, same size, we know what that means, and as far as front as behind. Now I'm going to look at question number 2. Now, you have to draw this properly. So, with a wing and a prayer, this data pen will do it right. So there's that, and it's a mirror. So that's its moustache. That's the silver backing. And carefully at right angles, I draw the other mirror. And there's its moustache. Yes, so you see what I've done so far. So now we'll go back over here. All over machine. Right, so I'm going to draw in a ray at 27 degrees. So I'm going to draw in a normal. So remember, you have all this to do, and then submit it to me. I'm going to draw in a normal. There's the normal. I know this at right angles. And carefully, you can hear me taking up the protractor here, marking in 27 degrees. So there's the 27 degrees, and hopefully with a wing and a prayer, that's it, and the arrowhead showing the direction that it goes. Right, there you are. So that's the question in the book. And it says, copy the diagram onto graph paper. I haven't got graph paper. And draw the normal to the mirror. So there's the normal. 1 mark to that. Fair enough. See the right angle where the blue spot is? That's the right angle. Normal. So I'm just going to label it normal. And I've shown you in class how to draw at right angles. Use the protractor. So, calculate the angle of incident. Now, warning, warning, that's 27. The angle of incident is measured from the normal. It's that angle. What's the blue spot? Look into my eyes. No, that's a different story. Right, so that's 27. So take the calculator. Don't get it wrong because of laziness. That angle there is 63 degrees. I have it labelled. Now we know that when this strikes a plane mirror, it comes off at 63 degrees. So you can hear me lifting the protractor here. I'm setting it on the normal. I'm finding 63 degrees. I mark a dot. And there's my 63 degrees. So, there's it coming off. That is 63 degrees. That is 27 degrees. So it says, calculate the angle of incident and the reflection at the point A. There's the point A. So it did that. So the angle of reflection is 63. On your diagram, draw as accurately as you can the reflected ray from mirror 2. So there's mirror 2 over here. There's mirror 2. So I'm going to continue that line on now. See, there's going over right to there. Now I'm going to try to work out these angles. That's 27. That's a right angle. So that there angle has to be 63. See that one there? That's 63. So that's 27. That's 27. I'm going to draw a normal in here. Again, you take your time and do this right. There's the normal. I'm going to label it normal. So it's going to bounce off. So I take my protractor again. Listen. That's it there. And I measure 27. There's the 27 measured. And it's going to bounce off that. And that's 27 degrees. Measured from the normal. Measured from the normal. See? See the way the slippy examiner give you that at the very start? So there's it drawn properly. Look at the arrows and all, everything's done. So let's see. Copy the diagram on the graph here and draw the normal. Got a mark for that. Calculate the angle of incident and the angle of reflection at point A. There's the angle of incidence, 1 mark for that. Now a mark for that. Angle I equals angle R, measured from the normal. And on your diagram, draw as accurately as you can the reflected ray. So there you are. 2 marks for that. 27, 27, full marks for that. Happy enough? So you're going to have to produce that for me. So now, that was question number 2. Now I'm going on to do question number 3. Right? So, it says figure 36.23, there's it below you, shows a ray of light incident on a glass block. Some of the light is reflected at the top surface, and some of the light passes through the glass and is reflected at the opposite side, which is a mirrored surface. So, let me do a quick sketch of this. So, again, you should be using a pencil for this, and if you make a mistake then you can't correct it. Unfortunately I don't have a data pencil, but I do have a data pen. So there's the glass block, and down at the bottom there's the mirror. I'll put a moustache on it to show us a mirror. Look, there's the mirror. So there's the mirror. It's exciting bit watching this video. So I'm going to have a ray of light coming in here. There's the ray of light coming in. And there's the arrow showing us coming in. I'm going to draw a normal. Now carefully using the protractor, listen. There it is. I've used the protractor to draw a line at 90 degrees. And there's the normal. I'll label it normal. Not much normal of it here. Right? So what happens? This bounces off. So I use my protractor again. What angle is that? I reckon that is 60 degrees. So I'll mark the other one 60 degrees. That's going to be 60 degrees. And there's the reflected ray that comes off. There is the reflected to bounce off. I'm going to stick the BDI up here. There's the BDI. Fair enough. Oh, that line didn't come in. I better draw it again. Naughty data pen. There we are. And the arrow. Lovely. I know that that angle is 60. And this angle is 60. And that's the reflected ray. That's the reflected ray. Now there's another ray. Here we have, this out here is air. And here we have glass. So there's going to be refraction here. We're going from less dense to more dense. So less dense to more dense. So here we're going to have LTM. Less dense to more dense is refracted towards the normal. Now, hopefully, I keep watching this screen and try to draw a straight line at the same time. Hopefully, you're getting, that's supposed to be a dotted line. That's the way that ray of light should go. But it doesn't. It bends towards the normal. So it's refracted towards the normal. And there it is. Refracted towards the normal. Right? See the way? It should go straight on through, but it bends towards the normal. Now, down here, there's going to be reflection at this plane mirror. So I'm going to draw another normal in. Now again, what is a normal? It's a line at right angles. So there's the line at right angles. Yes? See the normal? I used a protractor to draw that. So the angle, it's going to be reflection here. So this angle of incidence should equal the angle of reflection. So carefully, I'm going to try to make sure that it's as accurate as I can make it. There's it there. I've measured the two angles. I used my protractor. And there's that line going up. So there's the line. It comes in here. Here's where it's refracted. It comes straight down here, strikes the mirror and is reflected. So that angle, do you see that angle where that blue dot's sitting, is the same as that angle. And you can only make that the same by measuring it. So then the ray of light comes up here. Now, drawing a normal in. There's your glass here. See where the blue dot is? There's your glass. There's your air. MAL. We're going from more dense to less dense. We're going from more dense to less dense. What's the blue dot? We're going from more dense, the glass, to less dense. So right then the mnemonic. More dense to less dense. Away from the normal. Right? So let's draw this. This is the way I'm going to try to draw. Maybe I'll change. I'll try to be really upmarket this time. I'll use a red pen. Oh wow. So this is the way the light should go. But it is refracted. Look, it's refracted here. Because light travels faster in air than glass. That's why it bends. And it bends, look, over here, away from the normal. So there's my high-tech firmer back to the black. So it comes back out again. There's it there. Look. It should go straight on. What's the blue dot? It should go straight on, but it doesn't. It bends away from the normal, so it comes up like that there. Fair enough? Now, you have to use a ruler and a protractor and a good sharp pencil for that. And if I don't see evidence of that, I'm not giving you the mark. It's 3 marks. Copy the diagram and complete the path. Right? Copy the diagram and complete the path. So, that's it. That is it. And that's the 3 marks. So you get a mark for that one, and you get a mark for that one, and you get a mark for that one. Right? See the marks? There's a mark for pens like myself. There's a mark for over here showing that reflected ray. There's a mark here for showing this reflected and reflected. Look, that's refracted. That's bent. Here it is reflected. Do you see that one? This reflection here at the mirror. And then it comes up, and then because you're going from one interface to another, it's refracted, so it bends away from the normal. See the way I use that? And then don't forget this on mnemonic. I didn't highlight that, I suppose. Less dense to more dense. It goes towards the normal. So this is this one here. Do you see that one? Look, that's a mnemonic. Towards. Left. Fair enough. Now, there's those 3 questions done. So what I want you to do now, I want you to produce a page very similar to that. I wonder, can I zoom out? I'm going to try another bit of high tech here. Yes, I'm really on fire. Right, there's what I want. I want an A4 page. Take it from me, this is an A4 page. I want an A4 page. I want it to look similar to that. I want to see high quality work. And I want it uploaded into Google Classroom. Is that fair enough? I look forward to marking all that work. Remember, if I don't have evidence, you get 0. Thank you. Bye.